Okay, good afternoon all. Right, so today we want to start our new topic, database management systems. Okay, so database management system is our eighth topic. Okay, eighth topic. So then you have on two more big topics. Okay, so then syllabus is pretty much done. Now we are into the middle part. And today we want to finish introduction to DBMS and we want to start data analysis. Okay, right. Straight away, first I will show you the syllabus. This is topic number 8, database management systems. So first we will look at a bit of data versus information. Anyway, we have already discussed that. Structured versus unstructured, definition of database, database models, right? Comparison of database models. So then we will look at relations, tables, but rather than coming here, we do this one because your syllabus is pretty bad in that sense. So after doing this, right, 8.1, we move on to 8.4 and finish 8.4 because this is the analysis and modeling. Okay, this analysis and modeling. So after doing analysis and modeling, then we'll come back to designing part. Designing part, and then the SQL. So that is how we are going to do. And then you have another designing topic called normalization. Okay. So after doing this normalization and all the designing, we do the SQL as the last part. Okay. So we will be doing this part 8.3 as the last topic. First we will do 8.1, then 8.4. Okay. So then 8.2, then 8.5, right? 8.5 and 8.6 and 8.7. And finally, we'll get back to 8.3. Okay, so that is how we are going to do. That is a logical way of doing things. Okay, right. So let's start introduction to database management system. So again, the note is available. I just now uploaded a new note for that. Make sure you download the new note. Okay, from the database topic. Right. So this is a very small topic. It won't take more than half an hour. And this is very important topic because if guaranteed you get second paper part B question from database. If you understand, it's very easy. And sometimes you get structured paper question also, right? 2 questions. And of course, plenty of MCQs as well. Okay, so these are the big topics: network, database, programming, web development. So those are the big topics. Right. Introduction to database management systems. So this is the syllabus at high level: introduction, data analysis, design, development of SQL, and bit of security and other aspects. Okay, so we go like that: analyze, design, develop. Okay, so this topic is all about introduction to database management system. Right. So database management systems, as the name suggests, are used to manage data. That is why we said data management system or database management system. Right. So you know the difference between data and information, right? That we discussed in the very first day. So data is super important for us. So data is attributes of entities like name of an employee, price of an item, marks of a student. So that is data. Then information is processed data. Sometimes data is good enough, but sometimes we need the process information, right? Price of a item is, yes, good, but sometimes what we need is the bill total. Marks of a student is data, good, but sometimes what we need is a score. So therefore, whether it's data or information, we need to store it, store it until process it, and even after process it, we need to store. Especially we need to store data because information is processed and we get it, right? So that is what is meant by data management, right? Managing data. So when we say managing data, implicitly managing information also. Okay? So this involves save or persist data, update and delete data, retrieve, save data or information. Sometimes retrieve, process and show it as a report. Sometimes process data is also saved. So those are the three key aspects: save, update and delete, retrieve. Then there are other aspects in data management: security, preserve consistency or integrity, backup and recovery, transaction handling, performance. So those are secondary use aspects. So we can't forget about this also. But in your A-level ICT syllabus, so we are more interested in these things: save, update, delete, retrieve, and also preserving integrity is one of our major concept of idea in A level. So we have lesser focus on security, backup and recovery, and transaction handling. So you must know what you are supposed to know well. What are the things we just overlook? Okay, so we are going to dig into these things. We are going to just, you must just aware that these are also important, though we don't do it in A level because we have a limited time. But if you go into a degree program, so definitely you will learn about securing data, backup and recovery, transaction handling, performance improvements, and so on. Okay. So have that very solid mindset. Okay. Right. So if someone asks what is data management, now do you have the world best answer? So which include save, update, delete, retrieve data, plus other services like security, integrity, backup and recovery, transaction handling, and performance improvements. So this is not only in A level, whether you go to a degree program, MSc, PhD, data management is this. So your answer is not going to be changed. Okay. Now, data management is super important subject as well because there are a lot of job opportunities these days for data scientists. Okay, especially data scientists, data mining, data analytics. So that it doesn't mean that just learning databases will make it, right? Of course, database programming, AI, but those job areas, data management is your core competency. Other competencies help build on this. Now, you guys must think beyond A level also, right? Because you live in 2025. So I did my A level in 1993. At that time, our only objective was going for university, getting the degree. Because we had only government universities, there was only one path, right? But you have so many options now, right? So many options. You can attend to a state university, private university, right? Maybe you want to go in some other country and live, migrate. So keep all these options open. So therefore, don't just concentrate on A level, okay? You guys live in 2025, the world is very open, right? Lot of opportunities are there. Right. So why do we want to manage your data? Because we need to keep track of important data, right? We need to keep customer details, payment details, student details. It depends on the organization. Tax details, appointment details, channeling details, prescription details, booking details. So we need to keep track. Now, how do you keep those? We keep those in databases, right? And some data we need for decision making, right? So by processing these data, we get some summary values. Okay, summary values, graphs, see the trends. So that is what business analytics and data mining. So all these things are possible because your data is in good shape in your database. Your accounts, your final accounts, profit and loss calculations, balance sheet. So all these are possible because your database have all the information, data, right? Decision making. So this is super critical. So this is sort of a heart of your business organization, your data, especially when we living in the era of information. So your database is critical resource of your organization. Right. So let's move on to the types of data. So in your syllabus, they have break it into structured data and unstructured data. But I just divided into three. But pay more attention to structured than unstructured. Okay. But in reality, in real world, because your syllabus is set up about now 10 years ago. Okay. Yeah, I think very close to say 10 years ago. About 7, 8 years ago. So therefore, that time they break it as structured and unstructured. But these days we talk about structured, unstructured, and semi-structured data. So therefore, I just break it into three, right? Structured, unstructured, semi-structured. Structured data means data with well-defined structure. The word itself says, like student information, payment information, your bank account information, right? Bank account number, interest rate, account type, current balance. Okay. Say student details, student ID, student name, contact number, gender, address, date of birth, structured data. Appointment details like appointment ID, appointment date, appointment time, reason, structured data. Your exam results, subject marks, index number, structured data. So then the other end, you have unstructured data. So this is structured data. So structured data is the one that we are most interested in your A-level ICT database subject. Actually, this is the only one we are interested in your A-level ICT. And this used to be our main focus in IT field, managing structured data. Till about 5, 6 years ago away. So till about 2000, 2010, pretty much we save, modify, manage structured data. But now it is different. Now we manage unstructured data as well. Unstructured data means data having very little structure. Mostly these are multimedia data. Sometimes we call it big data because this data is generated in big volumes. For example, right now this session is recorded also. So at the end, I will upload it to maybe after few days. I upload it to YouTube. So that is at least about 400 megabyte of video. That is a big data. That is unstructured data. TikTok, Instagram, YouTube, Facebook generate volumes of unstructured data. Google Maps, CCTV cameras generate volumes of unstructured data. Now almost every new vehicle has dash cam. So every second they generate data. And self-driving car is all about processing these unstructured data, keeping the lanes, autonomous driving, robotics. So we can't forget about unstructured data. Actually, unstructured data is super important these days, right? But only thing is in your syllabus, database management system, we are not going to look at it. Big data, multimedia, because we need special databases to store this and special ways to process it. Okay. So the third category is, of course, in your syllabus, it's structured versus unstructured. Okay, but I just included a third category in case there's a question, maybe MCQ, unstructured data. Okay, sorry, semi-structured data. Semi-structured data means I did not include any slide, but I just included here. Semi-structured data means it's not as structured as structured data. At the same time, it's not as unstructured as unstructured data. It's bit of in between, right? Bit of in between. Somewhat structured, but not well structured. Okay. So there are some technologies like JSON, special databases like NoSQL databases to support semi-structured data. Okay. Right. So your syllabus referred to as structured and unstructured. Right. So little bit of evolution of databases or data management. Of course, these days we heavily use database management systems. Right now we are here. But we evolved from physical data management to computer file base to databases. So even before computer was invented, thousands of years, right? Thousands of years we have been managing data, of course, right? So especially the governments or kings, they manage tax money, registering people, right? Managing data. Individuals manage their data, I mean, their income, expenses. So how did they do it? Using papers, pens, and so on, books. And still we use it. Still, sometimes we just keep our information data written to a book file, manual or physical file-based systems. So we use paper-based files, forms, folders, file cabinets. Maybe we can use manual indexes to fast retrieval, like some libraries still they have it, manual indexes, index cards. If you go to government offices, still you can see files of files like deeds and so on, manual file-based systems. So a lot of disadvantages. Corruption, people can easily change. A lot of physical space need required. These files get degraded and there's a possibility of getting caught into fire, flood. All those are big issues. Difficult to transfer because physically you need to transfer. Sometimes there's a vehicle coming from Jaffna to Colombo just to take a file, maybe to sign. Waste of money, waste of effort, waste of resources. Stupid thing, right? Using manual file-based systems in 2025. But some people still do it, right? Right. So then came the computer file-based systems. When the computer was invented and electronic computers became more and more general purpose, like 1970s, 80s, people start using computer files. So that means now we save our data in computers, in computer files. And programs refer to these files, right? Different applications, payroll systems, order processing systems refer to these computer files, which is improvement, right? Compared to manual system, no physical storage. We have a soft copy, easily we can copy, duplicate. We can transfer it to some other place within split of a second using internet or email. We can easily back up. Okay. So it's much better approach. At the same time, there were some issues with computer file-based system. Like there were no standard format. Different programs demand different file formats. So then you need to duplicate your data because this file is not supported by that program. It expects different file. So then you need to transfer this data into that file. So therefore, and also security issues. Okay. So it's good. It's better than manual file base. But then came a better solution than computer file based systems. So what is that? Database management systems. So from 1980s, early part of 1980s, and people start using database management software to save our data rather than saving it in computer files in raw manner. Computer file means like a text file. Okay. For example, if you take a text file and save it like this, I'd say this is index number, say Nimal Pereira, say this is marks for ICT, say this is marks for engineering technology and so on. Say this is my next record. So this is computer file based system. So if you save like this, and if you save like this, so we call it computer file based system. So then different concept go into different files, which is good, right? Which is better compared to manual files because you can transfer it fast, back up it. You need just hard disk or SSD storage. But when it comes to database, it has a lot of drawbacks. No, not consistent. No formal structure. No standard structure. Processing file is not very efficient. Time consuming. Programming is difficult because you need to then write programs like your Python program, Java programs to read the file, go to the correct record, read it, or update it. So programming also difficult. That is where database management systems are very handy. So your software called database management system handles all your data, saving, update, retrieve, delete. Not only that, even security, performance, transaction handling, integrity or consistency handling. So all are handled by DBMS. You just need to configure it. And also your programs can communicate with the database using something called SQL, structured query language, which is much easier than file handling because SQL is something like structured English, select all from employee. select salary from employee where department number is 5. It's like talking to someone. So it makes software development also easier. And we have standard structures, standard data types when it comes to databases. Okay. Right. So that is why now we use database management systems rather than computer files. Computer files are used in some very rare situations, like a log file or something, but not to save data. Right. Now you know how it evolves. Manual file-based systems, what are the drawbacks? Computer file-based systems, what are the improvements and what are the drawbacks? And computer databases or database management systems, what are the advantages? Right. When it comes to database management systems, it's a software like MySQL, Access, Oracle, Microsoft SQL software. So these software or the database management systems also evolved, went through some changes. So it all started somewhere around 1970. So actually that, yeah, some latter part of 1960s also. Let's say 1970s, say to 2025. So first they tried hierarchical DBMSs. So then network DBMSs, relational DBMSs. That is what we are going to discuss in your syllabus. Still the most popular. Object relational databases, object databases. And now we even talk about NoSQL and some other databases. Okay. Right. So let's take one by one because it's in your syllabus. Hierarchical database management systems. So this is the first type of database management. Now this is after computer file based, right? Your DBM is software handling data, saving, update, retrieve, and we should be able to talk to the DBMS. DBMS must handle internal things. So what is hierarchical DBMSs? Tried out in 1970s. So you know that when it comes to organizations and so on, there's a hierarchy. For example, if you take a school, principal is there, section heads are there. Okay. So then class teachers and up to the students. So in a lot of organizations also like CEO, department heads, branch heads, and so on. Then the other employees. So, so they thought because organizations are pretty much hierarchical, why don't we just create databases also like in a hierarchical manner? That is pretty common sense, right? Pretty common sense because you need a starting point. So they thought, okay, if organizations are hierarchy, their data must also be hierarchical. So that is how they came up with this approach. So there our data is hierarchical. Okay. If you take something like organization, so we can think of finance related data, marketing related data, HR related data, production related data. Then finance related data may be assets, liabilities, and so on. Fixed asset, current assets, whatever that makes sense, but it must be hierarchical. Right? Hierarchical. Hierarchical means every data element has one parent element. There's no possibility of two parent elements. So that you can't have this kind of a connection. Then it is not hierarchical. There's a very strict hierarchy. And pretty soon they found, yes, it has a lot of control, which is good. So the main advantage is we get a lot of control over data because it's a strict hierarchy. But they found that this lacks flexibility because we now talk about data, not organizations. So we need to relate data, one set of data with another set of data. But if you go for hierarchical databases, we need to go through this hierarchy. So if I want to relate these two data, I have no other option but going through this hierarchy and relate. There is no quick and easy way because it's hierarchical databases. So therefore, though we have very good control, it lacks flexibility. It's very rigid, inefficient when we relate data. It's like student versus results of a particular exam. But you need to go through this hierarchy to relate. There's no direct connection. So that is how they came up with the other approach, network databases. So don't think that this has anything to do with the computer networking. No. Sometimes students think that okay, network database means this database is in different part of a computer network. No. Right? So this is not computer network databases. This is network databases. Network means freely interconnecting. Freely interconnect. When we freely interconnect, we call it a network. Like your friends. So you may be connected to many friends, but it doesn't restrict me to have a friendship with your friends. Right? So there's no hierarchy, there's no hard and fast rules. So that is other extreme because hierarchical approach very strict. Network approach almost no restriction. If you want to relate two things, you relate it. If you want to relate two things, do you relate it? Freely we can interrelate entities or tables. So this approach is called network databases. Again, network doesn't mean computer network, right? So your database is in one machine, but these tables are freely interconnected. So then we get very high flexibility because that was the issue with network hierarchical database. But at the same time, especially if you misuse it, we lose our control. Therefore, there can be a lot of inconsistencies, right, when it comes to relating data. So basically, these are the two extremes: extremely tight approach, extremely liberal approach. So extremely tight approach lack flexibility, extremely flexible approach lack control. So therefore, now we have settled somewhere in the middle, and we call relational databases. Now, network databases also came somewhere around early 1980s or latter 1980s. But now we have settled for something middle ground. We call it relational databases. So relational databases are not as strict as hierarchical databases, not as liberal as network databases. So that means we have some control, but not very strict control. Okay, so we can't say we have no restrictions. There are restrictions, but those restrictions are more reasonable restrictions, not tight hierarchical restrictions. And those restrictions are defined by there's something called relational theory in mathematics. So therefore, there's a theory behind relational databases also. So therefore, relational databases has become very popular because it is a good mixture of control and flexibility. So the main advantage, a good mixture of control and flexibility. Okay. And this is the most widely used. But again, this is not the ideal. Actually, there's no ideal solution to any problem, right? When we change our requirements, so then one's good solution after sometimes become okay, not that good solution. So therefore, anyway, it's still relational databases are the most widely used, but it is not the ideal or ultimate solution because our needs are keep changing. Especially now we are more and more using semi-structured data. So therefore, yes, right now the most widely used approach is here because it's reasonably good control and flexibility. But the key disadvantage is lack of support for object-oriented programming. Lack of support for object-oriented programming. Because relational database management system came before object-oriented programming concept evolved. So relational databases came in 1980s, latter part of 1980s, object-oriented concepts came in 1990s, early part of 1990s. So therefore, obviously, relational databases never thought of object-oriented programming. That is the biggest disadvantage, but anyway, that is not a very big disadvantage, but somewhat disadvantage. And also, relational databases are again good for structured data, not that good for semi-structured and unstructured data. So therefore, this is not the best solution. Actually, there's nothing called best solution, but this is reasonably good solution for structured data. Okay. So these are some popular relational databases. So the most popular relational database in industry is Oracle. Second, Microsoft SQL. Next, we have MySQL and MariaDB. MariaDB is the first version of free and open source version of MySQL. So therefore, pretty much MySQL and MariaDB is the same. So these are the big databases. Then the small databases, we have Microsoft Access, MS Access, Open Office Base, and so on. But those are personal databases. These are the commercial enterprise databases. We will be using initially Microsoft Access to learn our basic concepts. So then we will move on to MySQL or the MariaDB, especially for SQL. Right? So your syllabus refer to MySQL, and but anyway we will use Access initiate because it's easier to learn concept using Access. So then come back to MySQL. Okay. But you must aware that these are also popular database management systems, relational database management systems, Oracle, Microsoft SQL. So any questions up to this point? Right. As I told you, relational databases came in 1980s, but object-oriented programming concepts came in 1990s with C++ and Java languages. So obviously, then relational databases lack support for object-oriented concepts. Object-oriented concepts are like inheritance, encapsulation, polymorphism. So those concepts are not directly supported by relational databases because relational databases came before object-oriented. So that is where another type of database came into the picture. We call that object database management systems. Right? Object database management systems. So object database management system means you can save objects. Objects. In relational databases, you can save records. Records. But here we can save objects, which is more compatible with object-oriented programming. So then programming is also object-oriented, database is also object-oriented, which is more compatible. Right? So we call those object databases. But we are not going to discuss object databases in your A-level ICT because in your A-level ICT syllabus, we even don't talk much about object-oriented programming. So your programming subject, we only concentrate on structured programming and just a tiny bit of object orientation, just a tiny introduction. So therefore, obviously, we don't talk about object database management systems because we don't care much about object-oriented programming. Just we don't care, right? It doesn't mean that the industry is heavily using object-oriented. But these object databases are still evolving. So therefore, even though we use object-oriented programming, still we heavily use relational databases for the backend. Right. So network databases, sorry, hierarchical, network, relational, object. So we need to talk about another approach, that is object relational database. So this is like if relational is petrol vehicle, object is electric vehicle, object relational is like hybrid vehicles. So that means it support both new object oriented concepts and all relational concepts. So it's best of both. Okay. So therefore, rather than using object databases, some people prefer to use object relational databases because uh, you can use it as a relational database as well as object database or mixture. Okay, right. So that approach is also there. Right. Any questions? Uh, so I did not discuss one type of database, that is NoSQL database. Right? Because NoSQL databases are not in your syllabus, but just remember NoSQL databases are more popular for semi-structured data. Anyway, I will add a slide for that also because we never know. Examiner might ask question, maybe MCQ, though it is not directly in your syllabus. So NoSQL database is supporting semi-structured data. And the most popular NoSQL database is right now MongoDB. MongoDB. Okay. So shall we ask ChatGPT what are the most popular databases right now? Just to check whether ChatGPT is strict with relational databases or maybe give MongoDB also. What are the top five most popular DBMSs? Definitely Oracle will be there, MySQL will be there. Right, Oracle number one, MySQL number two, then Microsoft SQL will be there. Yes, I hope next one may be MongoDB. No, it says PostgreSQL, right? It's another relational database management system. These are all relational RDBMSs. What we discussed is RDBMS, relational database management system. Now it says MongoDB, fifth one. You can see it's no SQL. It's more flexible. That means semi-structured data support. Semi-structured data support. Okay. Got it? Right. Now we move on to database architecture. Database architecture. So this subject is serious subject. Now we are into the serious three subjects, right? Database, programming, web development. And three second paper part two questions from one each. Right. Database architecture. So again, we are more into the relational databases. Now from this point onwards, whatever I explain is relational databases because that is what we are interested. Right. So this is how you look at the database. So we have the end users. So they use different applications, right? Order posting system, inventory system, payroll system, leave management system. So basically their UI is connected to their application, Java, Python, web-based application. And your application communicate with database management system using SQL. Structured query language. That is our final topic, subtopic, writing SQL. And your DBMS can communicate with your database. Database means basically data files. Now the good news is our program doesn't directly communicate with the files. So we communicate with DBMS using SQL and DBMS can access files. That is something DBMS do. We don't need to worry about that. That is why now the programming is easier because we develop this and also we write this SQL. Writing SQL is not that difficult. But writing program to read files, update files is it's not impossible, right? It's time consuming, a lot of coding needed. Is it clear how the but when we learn database management system, of course, we are not going to communicate with database management system through application. Rather, through query interface or some interface, we are going to directly communicate with SQL because we are learning databases. We are not learning programming. This one we learn in programming subject. Right? So therefore, what we do is we are having a shortcut. We directly work with databases, designing, querying, using some tools because programming is our next subject. There we will discuss how your program connect to databases, how your web application connect to databases, how your uh, Python application connect to databases. Is it clear? If I'm going too fast, let me know, right? I can slow down. Actually, we are going very fast, right? So we are into the final part of your syllabus also. Right. So this is called three-tier architecture of database. It's a layered architecture. Layered architectures are not new to you guys, right? Remember we discussed about computer as a layered architecture, hardware, firmware, system software or the OS and application software. We look at the 7-layer OSI architecture, physical, data link, network, transport, session, presentation, application. So therefore, layered architectures are not new to you, right? You know the beauty of layered architectures. It makes us very easy to understand the concepts because lower layers support the upper layer and ultimate usage is in the top layer. Here application layer like HTTP, FTP, here application software. So in similar manner, we have for databases or especially for the relational databases, but in general for any databases, a three-tier architecture. This is ANSI architecture. This architecture was proposed by American National Standard Institute. Forget about this. This is their project name. ANSI three-tier architecture. So they came up with this three-layer architecture so that every database vendor with Oracle, Microsoft, so they respect this architecture. So what are the three layers? Internal law physical layer or schema. Logical law conceptual layer or schema. External law user layer. Internal law physical, logical law conceptual, external law user. So we'll go from top to bottom. So the external layer or user layer is end user's view. End users means like cashiers, managers, storekeepers. So they interact with your system. And when they interact with the system, they basically indirectly interact with the data or databases. For them, your database is set of forms, reports, and views. So they don't care about the technical things like files, tables. For them, this is their view of your database. That is what we mean to do. We don't want to expose them to technical things. These guys have their own work. It's a high level thing. So if someone talk about a form that used to enter data, so that it ended up in a database table, some reports generated by retrieving data from database, but that report itself is part of external scheme, external view. Now, when it comes to these end users, when it comes database designers, database developers, software developers, so their view of database is set of tables and relationships, so set of relations and relationships. Another name for table is relation, relations and relationships. न्याय सह न्यायदैकम. That is called logical or conceptual schema or layer. The lowest layer is the reality, right? Ultimately, your data must be set of files because even operating system is set of files. So those are data files and index files. You will better understand what is index file, okay, later. So this is called internal or physical view. This is what the database admins view because they need to take backups, performance tuning, security. So they need to refer to these files. For example, backup, they need to copy these files. Performance improvements are mainly done by changing these file structures, indexes, and so on. So this is called ANSI 3T architecture. Now, is it clear? So the lower layer support upper layer because ultimately the end user is interested in this layer. But this layer cannot exist without the lower layers. Right? External layer, logical layer, internal or physical layer. Now let's look at your database as a logic. Your database as a logic. Something like the logical layer view, designers, developers view. We look at the database as set of tables or relations. Of course, there are relationships between these tables also, but we are only interested in data. And each table or relation has records. And each record has set of fields. So your employee table has employee records. Department table has department records. Payment table has payment records. And each payment record has set of fields. And when we collect these related tables together, we have the database. That is called logical hierarchy because this is how we look at as developers, designers. Actually, this is the most important for us. But if you are a system administrator or something, where you are interested in monitoring, performance tuning, backup recovery, security, so you are interested in physical hierarchy as well. So for you, your database is set of files, data files and index files. And each file has records, right? Each file has records. And each record has fields. And because it is physical layer, ultimately each field is consisting of set of bits and bytes. So this is the physical data hierarchy. So rather than tables, now we look at it as files. Right. So this is again the 3T architecture. External or end users view, logical low logical law conceptual view, physical law internal view. So this is physical law internal schema, conceptual law logical schema, external schemas. Different users can see your database as in different way. Managers view is different from the operator. Same database, but operator is given restricted access to the database for their usages. Right. So then there's something called physical data independence and logical data independence. Now, this is an interesting concept if you are a serious person. So, physical data independence means when you design your database, set up your database, so you must be able to, or the database management system support this feature. If the DBMS support physical data independence, which is almost all the DBMS support, you can do some changes to the physical layer without affecting the conceptual or logical layer. For example, say your file was originally saved in C drive. Now you decide to save it into a D drive data file. So this should not affect your tables, relationships, and so on. That is called physical data independence. You can change the physical layer to some extent without affecting the conceptual or logical layer. That is called physical data independence. At the same time, we can do some changes, not all the changes, some changes, limited amount of changes to the logical layer without affecting the external layer. So that is called logical data independence. Okay. Is it clear? So when we say physical data independence, we can change the physical layer without affecting logical layer. Logical data independence, we can do some changes to the conceptual or logical layer without affecting external layer. Okay. Logical data independence, physical data independence. Right. So we'll take a small break. After the break, we'll continue. Now it is 5. We start at 5:07 and we'll finish this topic, okay? Introduction part. And at the end, we will do few questions also. 5:07. Okay, so let's continue. Right, so now we have discussed about the logical data independence and physical data independence, and also the 3D architecture. So the next thing is, when you look at a database or database management system, we can look at it as two parts. It's again the way we look at it. We can look at it as we are looking at the data, or we can look at it as we are looking at the metadata. Sometimes we call this data view, design view. But the official or the technical term is data metadata. Design view means we are looking at the metadata. Metadata means data about data. Right? So here we look at the data. That means some tables, their records. But here we look at what are the fields in that table, what is the primary key, right? Something like that. So then we look at metadata. What are the relationship between tables? Sometimes we call it design view, or sometimes we call it we are looking at the metadata, or sometimes we call it we are looking at the data dictionary or system catalog or design view. All these are the same thing. Metadata, data dictionary, system catalog, design view. So that means we look at that. We are looking at the data about data, or we directly looking at the data of the database or data of the tables. Right? Data view versus design view. Okay. So metadata means what? Data about data. What are the table names? What are the fields of a particular table? What is the primary key? What is the foreign key? Don't worry if you don't understand these words. You will be familiar with this pretty soon. Okay. Right. So this is metadata. Right. What is the name of the table? What are the name of the fields? What is the data type of each field? Length? Do we have any restrictions like min, max values, uniqueness, with our description about the field? So that is metadata. Okay. Of course, data is like NIMAL, blah, 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 reports. Right. So this is another view. Don't take this very seriously. Right. Uh, Ultimately, it is files. Right. Your data is saved in files. So there's something called file manager in database management system. Remember your applications or programs or your SQL interface if you are just as a human communicating with database. That is what we do in our studies. Or your program, Python, PHP. So you send SQL queries, or your program send SQL queries. So then your DBMS has something called query parser that execute your SQL. Because ultimately your data is in files. But you send is SQL query, high level query. So then there's something called file manager, then there's something called security handler, backup and recovery handler, transaction handler that coordinate this. Okay, coordinate this. Because when you take backup and backup also, you need to work with file handler because it's you back up your files. Transaction handling also, you need to work with file because you need to lock files, lock records. So therefore, all these handlers uh, ultimately need to coordinate with file handler because file handler can work with data files and index files. But at high level, uh, it is a query parser interface that accept your SQL from humans or from applications. And intermediary, the security, backup and recovery transaction handlers are there. But low level, it is a file handler that work with the files. So don't expect that you will be asked to draw this. Don't worry, right? This is just to give you the big idea. But this is definitely you need to draw it 3 tier and okay. Right. So therefore, what are the major functionalities of DBMS? Of course, it need to do file handling, query handling, transaction handling, security, backup and recovery. Okay. So file handling means you need to handle the DBMS, right? Not you need to access file and insert a record, update a record, delete a record. So your query handling means accept your queries. So basically query handler pass it to the file handler, file manager. So transaction handling will handle transactions, which we will separately look at today. Security will handle security aspects because otherwise everyone will access your database. And backup and recovery. Take backups in case of a crash, recover it. So those are also part of the database management system. You just need to configure. Right. So we will separately look at on transaction handler because we are not interested in transaction handling anymore other than this. Okay. Query, of course, SQL is one of our big subtopic. These are self-explanatory, right? Backup and recovery means taking backups and in case of a crash, recover the database from the backup. Right. What is mean by transaction handling? Why we are interested in transaction handling here? Because in your syllabus, we don't look at it only other than this slide, these one or two slides. So just the big picture of what is transaction handling, that's it. We don't discuss about how it is handling databases, nothing. Right. What is mean by transaction? So that it has two meanings. In day-to-day business, transaction means some exchange of something. For example, money transfer. Money transfer is a transaction. So you go to the supermarket and buy something. So when you buy something, you need to pay by cash or credit card. So that is a transaction. A student registered for a course, it's a transaction. You channel a doctor, it's a transaction. You reserve a hotel room, it's a transaction. So transaction means some activity, business activity, which if it has some information, exchange of information, data, so that transaction is related to IT also, right? But in databases or database management systems, what is mean by transaction? So we are a little bit more serious now. So transaction is set of activities that must be success as a whole. We say that it's committed or fail as a whole. Say this is success, this is success, this is fail. So then you can't say three steps are success, two steps success, other two fail. So then you need to roll back. So that is what is meant by a success as a whole. Then we commit it or fail as a whole. Fail as a whole means if this is these two success and this is fail, you undo these two. So that it's like nothing happens. Either nothing happens or it fully happen. There's nothing called part happen. If partly happened an error, you need to roll back it. If everything is success, you need to commit it. So this is called transaction handling. So therefore, every transaction is either committed or rollback. That means success or fail. Success as a whole, fail as a whole. There's nothing called partly success, partly fail, because that is business rules wise illegal. Say you're transferring money, say you transfer money from your account to my account. Now there are two activities. Money is deducted from your account, money is added to my account. So if it is committed, both are success. But there can be a situation money is successfully deducted, but there are some errors when you try to transfer money to my account. Now you can't stop it and say, okay, reduction success, transfer fail. No, that is wrong. So if it cannot transfer money to this account, then this reduction must be reverse and give you the error message saying your transaction is failed. So then that is fine. Maybe you can try it later. But there can't be a situation where the money is reduced from you but not added to me. Either reduced and added to me, then committed, or nothing happens. So when you get error here, you need DPMS will undo this and say rollback. So that is called transaction handling. There can be 3 step, 4 step, 5 step. If at least one step is failed, it must undo all the previous steps. That is called transaction handling. That is what is mere success as a whole or fail as a whole. There's nothing called partly success, partly fail if transaction handling is done by your DBMS. Okay. Now, when it comes to transaction handling, there's a famous acronym. Acronym means something like the first letters of the words are used. Then we call it acronym. Okay. Like SSC, acronym. USA, United States of America, acronym. So when it comes to if the database handle transaction, it must make sure that ACID properties are preserved. This is not directly mentioned in your syllabus, but I just add it because it's good to know about that. Right? There's a rare chance that they can ask this in your maybe MCQ. ACID property. So ACID stand for atomicity, consistency, isolation, durability. So that means every transaction, if it is properly handled by your DBMS, must make sure it is atomic, transaction is consistent, transaction is isolated, durable. And what is mean by atomic? You know what is mean by atom, right? Smallest unit. And smallest hydrogen particle is called hydrogen atom. Smallest copper particle is called copper atom. You can't have smaller part of copper. So atomic means your transaction is the smallest part. Smallest part for success or failure. So as a transaction, it is either success or fail fully. Fully success or fully fail. There's nothing called 75 success, 25 fail. So that is called atomic. That is obvious, right? That is the definition of transaction. Success as a whole, fail as a whole. That smallest unit of success or failure is transaction. So then consistent means if your database is consistent with business rules wise, before a transaction, it must be consistent after transaction. For example, if your accounts are tally before a transaction, after the transaction also your debit credit must have been properly happened. And it must be again consistent. That is obvious, right? That is why we make sure that no partial success. Either success as a whole or fail as a whole. You can see we are telling the same thing in different ways. So isolate means there can be multiple transactions happening at the same time. Right? Maybe for ATM machines, all ATM machines are doing money withdrawal. Maybe all tables refer to the particular account table. So then each transaction must be isolated from others because there can be some inconsistency. So that is called isolate. That is important when we have multiple user sessions, parallel sessions. And durable means once the transaction is committed, it must be persistent. Even when you switch off your machine, it must be in your files. Right? So that is called ACID properties of transaction. Right, now we move on to database types based on usage and roles. So we can subdivide databases into three categories. Personal databases, work group databases, and enterprise databases. Personal database means this database is used by a single person, like Microsoft Access, Library Office Base. So you use your database, I use my database. You and I don't use the same database. Like you are keeping track of your savings or your expenses. I keep track of my expenses in my database. Your data is in your database, my data in my database. Another example is your mobile phone. You have address book, contact information in your mobile database. I my smartphone also has a address book that is in my database. So you don't connect to my database, I don't connect to your database. If those are called personal databases. Personal databases. Workgroup database means set of people use that database, but not a large amount of people. Maybe two, three, four as a big two team work group. So then you need bit more security, right? And bit of transaction handling. But not very serious, but little bit more serious than personal database because multiple users can access, but few users. But when it comes to business systems, order posting, inventory management, sales, we use enterprise DBMSs like a banking system, airline reservation system, supermarket, billing system. Thousands of transactions happen at a particular second. Okay, at a particular second. And also stock exchange. What about these big e-commerce platforms like eBay, Daras, Temu, Mastercard, Visa platforms? Thousands and thousands of transactions happening. Those are written to the databases. So you need very special databases with special security, performance, transaction handling, backup and recovery features. Because thousands or sometimes 10,000, 50,000 parallel transactions. So that is where we need enterprise DBMSs like Oracle, Microsoft SQL, MySQL. So personal DBMS like Access, Workgroup DBMS, enterprise DBMSs. Is it clear? Of course, if it is clear, you will naturally remember. Right. So now we move on to final aspect, people. What are the different type of people who work with databases or use or work with databases? So we can identify, of course, there are different ways we can categorize, but this is the simplest categorization. End users, designers, administrators. Of course, end users are just the users. They don't involve in designing development, right? So maybe a manager, receptionist, cashier. So they are the end users of a database. So they usually access it through their applications, right? Not directly. Maybe their web application, inventory management system, payroll system. They indirectly access the database, right? So that is end users. So then you have database designers and developers. So these are the guys who design your database based on your requirements. Identify tables, primary keys, foreign keys, that is relationships, normalization, and also create the database using SQL and maybe fill with records, initial data setups. So those are done by designers and developers. And the third category of user is database administrator, DBA. So they are not much involved in designing, but after the production level, so they are the one who take care of the database, production deployment. So they need to acquire the software like operating system, hardware, servers, right? You just give me 1 minute. Right, sorry for that. So they are the one who acquire software like operating system, hardware, set up the DBMS, right? Install and set up your databases, create users, monitor, backup in case of a crash and restore, performance tuning. So that kind of things. Basically, after the database is set up and software is deployed, so they take care of the production. Production. So you don't need DBAs everywhere, every system. Especially we need DBAs for banking systems, big systems, critical systems. Okay, critical systems. Right. Some quizzes, self-evaluation quizzes. Because you don't have much of a past paper questions from this topic, because past paper questions are from topic 2 or 3. There is analysis and modeling, then designing and SQL. All the questions are from there, right? Right. Can you answer this one? Because which of the following best describes a database management system? So you need to tell whether A, B, C, D, or E. Best answer. Anyone? Yes, answer is E. Right? Answer is E. Right. Second one. What term is used to describe information about data? Information about data. That is data about data. Hyperdata, teradata, metadata, big data relations. We discussed that today itself. Right? We call them metadata. Right? We call them metadata. Third one. What are the possible issues triggered by redundant data? Redundant means your data is in multiple places, same data. So this is something we have not directly discussed. We will discuss it in latter parts, but I just added it so that can you think of a possible answer? And it's basically a challenging question. So integrity means relatedness. Issues they ask. Okay, so issues must be negative things at least, right? Issues are not positive things. Redundant means duplication of data. Actually, one of the biggest issue of file-based system is redundancy. Same data is in multiple files. But when it comes to databases, redundancy is less because data is in central place. Same one particular data is in one place now. In old approaches, file-based, same data is in my payroll system, employee management system. So everywhere the contact number is there. Everywhere my date of birth is there. So higher consistency is obviously not an issue, right? If higher consistency it is better, but actually what happens is inconsistency because your data is duplicated. So then sometimes you update one place but not update other place. So therefore, redundant data means you have less consistency. So therefore, this is not an issue. This is actually good thing, but when we have redundancy, actually you don't get this. Reduce data integrity. Yes, integrity means interrelatedness. Interrelatedness is less. Right? Redundant data. That is yes issue. Lower the risk of course, if the risk of errors are lower, that is not an issue, right? That is obvious, you know. Performance issues, yes, because data is multiple pages means unnecessarily file size is bigger, memory, you need more memory, and also maintenance issues because your data is in multiple places. For example, if someone changed the contact number, maybe you need to go and change it in two places, three places. But if it is no redundant data, you just change it only one place. So the answer must be 2, 4, and 5. 2, 4, and 5. It's anyway, don't worry if you don't answer that one because that is a challenging question, right? Right, next one. In a database, which of the following reflects the transaction as permanent? That means you make your transaction permanent. How do you call that? Insert, commit. So permanent means success, right? Otherwise, rolled. We need to undo. When it is success only, we make it permanent. Otherwise, we have not yet make it permanent because we are waiting for the next step to happen and see if everything is done. It's we want to make it permanent. What is the term we use? Insert, commit, save point, rollback, flashback. So that is called commit. Commit to the database. Right? That is the term we use. Other word is what? Rollback. That is you undo things. Undo things. So either you roll back or commit. Okay. Roll back or commit. Right. So that is a bit of questions to check your confidence. Okay. Right. So we are done with the topic first part. That means we have done, of course, data versus information. We have discussed structured versus unstructured. We discussed. Okay. Definition of database. Right. What are the tasks of databases? Then file-based systems, hierarchical model, network model, relational, object relational. We even discuss about object database, and object relational is that it supporting both. Okay. And what are the pros and cons of these models, right? Hierarchical has a lot of high control but lack of flexibility. Network has a lot of flexibility but no control. Relational has very good flexibility and control, but lack object-oriented support. Object databases support object-oriented concept, but now what we most use is object relational, which support both. Right? But in your syllabus, we are only interested in relational databases, right? Right. Our next topic is the way we do it, uh, analyze and model the requirements. Remember, when we do system analysis and design, I mentioned you that we do only analysis and modeling process, context diagrams and data flow diagrams, and then additional things like decision tables, decision trees, structured English, pseudocode for detailed description of the process. So we skip data modeling. This is all about analyze your data related requirements and model your data related things. Okay. Uh, in the exams, what you get, if it is second paper question, most of the time your question is on this. They will give you a scenario and ask you to draw the ER diagram. We discuss not only the ER diagram, extended ER diagram. Extended ER diagram support bit of object-oriented concepts. Okay. Object-oriented concepts like inheritance. Right. So that note is also available, but I will upload an updated note for that. Okay, updated note, but you can download for the time being. Right. But maybe tomorrow morning I will upload the. Whenever I upload, I will send you a message saying new document is available. But anyway, we'll use this presentation for the time being. Okay. Right. Data analysis and ER modeling. Remember, software development we go through problem definition, feasibility study, requirement analysis, design, development, testing, deployment, maintenance, evolution, and reviews. So this is part of analysis. So you analyze process, you analyze data, P plus T in structured analysis. So this is all about analyzing your data and model it. Okay. So we will look at what are the different data models, what are entities, attributes, relationships, and last we will look at extended ER modeling concepts. First we will look at the ER modeling, then extended to the additional features for object-oriented support. So this is the big picture. When it comes to data side, okay, problem definition. And of course, here we have the feasibility. I have skipped it because we are more interested in data aspects. So then analyze your requirements. So here we are interested in data. So the result is conceptual data model or conceptual ER model. So once we model the conceptual ER model, so that models the requirements, data related requirements. So then we move on to designing. So when it comes to designing related to databases, we subdivide it into two, logical design and physical design. So logical design, the result is logical ER diagram. This is conceptual ER, logical data model or logical ER. This is after doing some design, normalization and so on. Don't worry, we are going in this approach, this way. That is why we do middle part and because your syllabus you do design, development, and then come to analysis. That is a joke. but we do it in a proper way, right? So then there's something called physical design that is specific to your database system. Whether it's Oracle or something, we need to do some fine tuning. Then we need to develop your database, create your tables, relationships using SQL, so that we can deploy. That is, you have set up your database parallel to set up your applications, your web applications, and so on. And then, of course, you use it, maintenance, and so on. Right. So today we want to start this part, requirement analysis and modeling the data. So this is not designing. We are not thinking about solutions. We just look at the requirements. Okay. So this is when it comes to design and analysis and design process, requirement correct analysis, conceptual design, logical design. So actually, this is not conceptual design, actually conceptual modeling. Okay, I will change that also because this is part of the requirement analysis. Then this is the design, then the implementation, that is creating the database and maintenance. Okay, right. So there are different type of models. So models are not new thing to you guys because we discuss context model, data flow model, DFD. Okay. Therefore, models are not new to you. So model represent your abstract representation of your system or any aspect of the system. So process aspect of the requirements we model using context diagram and data flow diagram. So model is abstract representation. Abstract means high level. We model only minimum essential. Right? Model only minimal essential. And we can model different aspects using different models, right? Process aspect in high level process aspect in context diagram, detailed process aspect in data flow diagram, and it has a variation called document flow diagram if you want to look at it from document point of view. And when it comes to data also, we can have data conceptual models, that is requirement, then design models, logical design model, physical design model, so many different models. So models are super important when you develop, design, understand complex systems. So in software development, we heavily use models. Engineers heavily use models. Those engineering drawings are models. Circuit diagrams are models. Machine drawings are models. Right? So those who are doing tech, other tech subject, you know what modeling is, right? Like engineering drawing. So here also we look at conceptual model after analysis, then logical model, then physical model. That is design. Conceptual model, that is requirement analysis. Logical model and physical model in the design. First logical model, then physical model. Then development of your database. Right? Conceptual model models what the system contains. Of course, we are interested in the data aspect, okay? Logical model is our initial design. And physical model is when we commit to the technology, like Oracle, MySQL, we refine our logical model into physical model. Here we are only interested in data models, okay? Right. So in this topic, we are 100% concentrating on conceptual data models because this is analysis. After analysis, we need to model our requirements related to data. Right. So these are the key terminology we use. Concept of entity, attribute relationships. So these are the three major things. Okay. So therefore we call it ER diagram, entity relationship model. Entity relationship model because your entity has attributes. So something like this. So this is an entity. This is an entity. This is a relationship. And this is an attribute. So entity relationship, because entity has attributes, we don't call it entity attribute relationship, just entity relationship model, ER model. Entities and their relationships. Is it clear? So then logical ER model is later on when we go move on to the designing, right? So that we will not discuss separate, not today. Then physical ER model is again at the designing stage when you commit to your technology, right? Like Microsoft SQL, MySQL, you refine your logical ER model into physical. So basically, we start with conceptual ER, transfer it to logical ER during designing, early stage. So then the latter part of designing, we convert it to physical ER. And then they implement the database, SQL, write it, deploy it. And of course, maintenance and so on. So these are the activities, okay? So basically, you must know what we are doing, right? Right. So now we are into the requirement analysis. Remember, gather requirement, analyze requirement, model requirement, document and verify, right? So this is modeling the requirements, but we model data aspect of the requirement. So the result is what? Conceptual ER model. Right. When it comes to conceptual ER models, the major concepts are entities, attributes, and relationships. So in the day one, I explained you that data is an attribute of an entity. Right? Data is an attribute of an entity. But look at the note number one. Okay, so what is an entity? Because now we are talking about ER diagram. ER diagram. So entity is anything that we are interested. Right. Anything that we are interested. Okay, let's forget about the related. Right. Anything that we are interested. As part of our system. Maybe we are thinking about developing a sales management system. So then, of course, what are the entities? Products, customers, right? Payments. So those are entities. Say we are thinking of student management system, students, course, lecturers or teachers, payments, registrations. So that is called entity. Entity. Remember we discussed that entity can be living physical thing, non-living physical thing, or it can be even conceptual thing. Sometimes the entity is called entity set also, but mostly in A-level ICT we use the word entity. But if you see somewhere entity set, that is just they refer to entity. Right? So what are the possible entities? Living physical things like employee, student, customer, patient. Non-living physical things can also be entities like a vehicle, item, machine, product item, drug item. Okay. So we are interested in this. Maybe we are interested in machine number, date of manufacturing, cost. So conceptual things can also be entity, like order, payment, account, cost. Okay. Is it clear? Because unless you understand entities and especially the difference between entity and attribute, you need to understand. Otherwise, how can you draw ER diagrams? Right. So when it comes to entities, we are interested what type of entity is that? Strong entity or weak entity? So then we are interested in what are the attributes of that entity. And when it comes to attributes, we are interested whether it's identifier attribute or is it a normal attribute where you can store or derived attribute, composite attribute, multivalued attribute. So that is related to entity. Right. So there are two type of entities. Strong entity, weak entity. Strong entities, a major concept, right? Major concept. Major concept is called strong entity. For example, if it is student management system, obviously student is a major concept, right? Employee is a major concept. So if it is employee management system, employee. So it depends on the system, okay? Cost, order, payment. So these are for different systems. But it must be major concept in that system or domain. Weak entities is not a major concept to our system, but sometimes we need that information. And it is related to one of the major concepts. So then we call it weak entity. Right? Weak entity. For example, if it is student management system, of course the major entities are student, teacher, course, payments, registration. But what about parent of a student? Of course, we are not teaching to the parents, but maybe in case of that student has some illness or something, we need to inform. If there's a miss sort of a disciplinary thing or something, we need to inform their parents. Other than that, we are not interested in parents in our education system. So then parent is a weak entity. Weak entity. Maybe employee management system. So employee is a major concept, strong entity, department, projects. But what about employee spouse? Spouse means husband or wife. Of course, spouse is not part of our organization. But sometimes we need to keep details about the spouse of the employee. For example, if there's a insurance scheme, health insurance. So usually you are not only the employee, employees, family members are also covered. So then we must know who are the spouse of the employee because otherwise, how can we track whether that is actually his or her spouse medical claim? So we need to know the details in our system. So then only we can verify that yes, this is a valid insurance claim, medical insurance claim, health insurance claim. So that is the only reason we keep that. Not because we are our spouse is part of our organization. So then spouse is again, spouse of the employee is a weak entity. Weak entity. Is it clear? Is it clear? Right. So the normal entities or strong entities are represented using single line rectangle. Weak entities are represented as double line rectangles like spouse, parent. Okay? Spouse, parent, and so on. Now we have the attributes. Attributes. So attributes are the properties of an entity. Actually, attributes are the data that we will be saving. Right? We don't save the entity, we save the attribute of the entity, right? For example, name of the student. We don't save a student, we save a name of the student, date of birth of the student, gender of the student, contact number of the student. So these are called attributes, properties of an entity, whether it's strong entity or weak entity. And these are represented by elliptical shapes connected to the entity. And remember, entity must be a singular noun like employee, payment, spouse. Attribute must also be a singular noun like employee ID, name, date of birth, salary. Okay. So make sure you are very disciplined when you mark your attributes, entities, giving names. Otherwise, sometimes the examiner will say, do not give marks. So this is an example. So we have different type of attributes as well, like this identifier attribute. This is multi-valued attribute. This is, sorry, this is composite attribute. This is multi-valued attributes. This is derived attribute. This is a normal attribute. This is another normal attribute. Right. Identifier attribute means that using that attribute, we can uniquely identify an entity instance or record. Instance of an entity we can uniquely identify, like student ID or student number, order number, appointment number. So that identify the instance. So when you model it, give that name and underscore, underline. Underline means that is the identifier. Okay. So then stored versus derived attributes. If the attribute we are going to save it, it's a normal attribute or stored attribute, like date of birth, gender, contact number. But there are attributes we can derive it from the stored attribute. So therefore, you don't need to save it, and sometimes saving is going to be issue. For example, age, every year age change, right? Maybe now it is 20, but after next year we need to change it to 21. That is headache, right? But if you save the date of birth, at any time we can derive the age. That is current date minus date of birth. So therefore, age is a derived attribute, which usually we don't save it. Okay, so we use this. So then designers know that, okay, we don't need to store this. We don't need a column for this. We only need this. Okay, stored versus derived. Next, composite attribute. Composite attribute means it's an attribute which we can subdivide into sub attributes. Like address, maybe we can subdivide into number, street, and city, which is very handy because if you want to search by city, then it's very easy because city is one field. Otherwise, city is part of your address. So then we can break it into composite attribute. We can break it into sub attributes. If it makes sense, only do it. Okay, use your common sense and you need bit of experience also. Sometimes we even break name into first name, last name, mid name, and so on. But in your A-level ICT questions, most of the time I have seen it, they take name as single field. So therefore, don't break it unless they mention it. Just keep name as single attribute, not a composite attribute. Okay. Because maybe the A-level ICT examiners think that, okay, let's keep it simple for that kind of. But address, definitely they break it most of the time. Right. So then the multi-valued attribute. Multi-valued attribute means it's an attribute, but there is a possibility of multiple values for that. So then you can use plural also. Usually attribute is singular. Name, date of birth, salary, but if it is multi-valued attribute, you can use a plural noun and also double elliptic shape, double line. So it shows that it is a possibility of multiple values, like skills. Maybe he will say, I have say language skills. I can speak Sinhala, Tamil, and English. One will say, okay, I can only speak English. I can only speak Sinhala and English. So multi-value, possibility of multiple values. These are important because when we design, you need to do certain things. Right? That is why we model these requirements. Right. So then we are into relationship. Remember ER diagram. Now the E part is done. How to model entities. Right. So now we are into the R part, relationships. Right. We will do the relationship part in the next class because it's a big topic. Okay. Big topic anyway now 6. Okay. Right. So we stop at this point. So the next class definitely we can finish this. That is ER modeling we can finish. So then of course, next class we can't move on to the designing, but we can finish analysis. So then the designing, uh, including the normalization, then SQL. Okay. So it will take another about 5 sessions to finish this. Okay. Entire topic. That means about 1 month. Right. We stop at this point. And the other thing is make sure you do your payments. Okay. Uh, because some students have not done the payments. So make sure you do your payments. Okay. And send me the payment slips. Okay. Right. We stop at this point. Thank you.